Yeah. Are we fine?
Yes.
We are fine. Yeah, now we want to move on with our next topic, that is topic 10. Topic 10. And Patience, are you okay? I saw you talking to Grace about this question that I'm going to ask. You are ready? Before you go on with topic 10. Now the question is just to refresh us in the minds before we move. You are ready? Tom's father has 5 daughters. Tom's father has 5 daughters. And each daughter has 1 brother. Have you picked that? Tom's father has 5 daughters and each daughter has 1 brother. How many children does Tom's father have? People's heads are boiling. Who is very, very sure? Everyone give his own view. We start with who? Precious. Precious says that Tom's father has how many?
Has 10 children.
10 children. Then Grace, 6 children. Then Patience, that he has 11 children. Could you defend why there are 10?
10, as you said, each daughter, there are 5 daughters. Each daughter has 1 brother.
Has 1 brother.
Yes.
So you added the 5 plus 5. Okay. Let's hear from Grace. Why did you say there, Grace? Why did you say Tom has 6? Why?
I say Tom's dad has 6 children.
Yes.
Because Tom is also a son of that dad. And then those 5 daughters, since they all have one brother, and that 1 brother is Tom, meaning there are 6 children.
Are you trying to defend yours? Or you are agreeing with Grace?
I want to interpret the English.
Interpret and we see.
Tom is the last child. So Tom's father has 5 daughters. And each daughter has a brother.
Yes.
So they will be 11.
There will be 11. I think the question was tight. But we thank Grace for having seen the answer. That even if you have 5 children and each has 1 brother, you still remain with only 1 brother in total, which is Tom. Yeah, thank you for being very, very attentive. And I think we captured the Precious offside and what? And Patience offside. Now, let us discuss our topic 10, and we are going to call it Algebra 1. Yeah. Now, under algebra, you know very well that students are familiar with 2 plus 2, but when we say A plus B, they now turn their heads offside. Now, algebra is just change from use of numbers to letters. Yeah, that instead of using numbers, instead where you'd have a plus b can be 2 plus 3, and here you'd know the answer direct, but here you'd try to refuse, not so? Yeah, that algebra is just the math of letters instead of numbers, but of course we can mix in also numbers here. Subtopics, we are going to look at the first one, generating formulas, generating formula, then using formula, yeah, then solving equations, but that one will first need us to visit a part that will let us solve equation, expanding brackets, then solving equations. Then we shall also look at functions and mappings. Yeah. And I think that's not too much. And within a short while we shall have what? Exhausted the work. Yeah, we've defined algebra already, that it is the math of symbols, but we can mix with the numbers. Hope you are very attentive. The head is working, because I saw it's working, but Grace's head seemed to work more. Or they were all working, but they were mistakes. Okay, now let us start with generating formulae and expressions. Yeah, generating formulas and expressions. Yes. Now, if a question went that Tom thinks of a number, I think you are acquainted with that language, of I think of a number, multiply it by 4 and add 2. Let me give this question. Tom thinks of a number. Tom thinks of a number, subtracts 5, and adds, subtracts 5, not and adds, and divides the result by 2. And divides the result by 2. Form an expression to represent the statement. How shall we deal with that? How shall we generate that? Yes, Grace, guide us to the generation of that.
I think forming an expression, you will have to first let the number that you have to do all the subtracting 5 and dividing the result by 2. So you'll have to let the number be any letter of your choice.
Like let the number be
N.
Let the number be n. Let number be n. Then the expression would be
N
n
minus
minus 5, divide the result by 2. Yeah, let me give this other one. I think you capture that down. Are you there? The price of 1 bag of cement. The price of 1 bag of cement is C shillings. The price of 1 bag of sand is 2s shillings. 2s shillings. 2s. And the price of the price of 1 bag of gravel is 3t shillings. 1 bag of gravel is 3t. Form an expression to represent the total cost of all the items. Form an expression to represent the total cost of all the items. Let me hear from them and we see. Who is giving us that? Only Grace, Precious, and Patience. I want your answer. Form an expression for the total cost. Oh yes, Precious seems to be ready. Total cost would be C shillings
plus 2s
2s plus 30s shillings. Thank you. Yeah, that's perfect. Now that generating expressions depends on what the statement is saying. That right? Now, I'll right away jump to using formulae. Using formulae. I think we are just in what you like most, not so? Yeah, you like algebra very, very much. So, somebody saying, you know, we start over, not so? Yes. Given that U is 20, A is negative 2, and T is equal to 5, find V if V is equal to U plus 80. I think the approach is we know it. Somebody can guide. Yes, Grace seems to be ready to guide. Okay, you can work it from here. You have two minutes.
Finding V if V is equal to U plus 80. So between these two letters we have a multiplication sign that is not shown. So we shall substitute in these letters with their meanings as given in the question. Because here it says given that Q is equal to 20, so the U will stand for the 20 plus A, which is negative 2, times, because between these letters there is a multiplication sign, times 5, which is which is 2 by t. Then we shall have 20 plus negative 2 times 5, negative 10. We get negative 10. So we shall try to work out that thing of a positive times a negative. It's a negative. So it will give is equal to 20 minus 10. So it will give us
Thank you very much, Precious, for being very, very fascinating. She has been very, very fascinating. Okay, we can continue on. You are ready there? Yeah, the volume of a sphere. The volume of a sphere is given by V is equal to pi r cubed. The volume of a sphere is given by that. Find V when the radius is 14 centimeters and pi is 3.14. Correct the answer to 1 decimal place. We have another discussant helping us there. The answer to 1 decimal place. Precious, try it. 2 minutes only are for you, and we move on.
They're asking us to find V when the radius is 14 centimeters, pi is 3.14. So we shall have to find V, the volume, which is like the volume, which is equals to 4 out of 3. And it's just like times the pi, which is 3.14. And then times, here is a hidden multiplication sign, times the radius, which is 14 centimeters. And remember, it is cubed. So volume equals 4 out of 3 times, this will change into 3.4 out of 100 times 14. This 14 centimeters cubed is just like 14 centimeters times 14 centimeters out of 3 times 3.4 out of 100 times 14 centimeters times 14 centimeters times 14 centimeters. So we shall have to first multiply these for ease of thinking. Volume equals to 4 out of 3 times 300. 14 out of 100 times 2,744. 2,744 So we shall support this with a leg by putting one there. Then we shall start dividing just multiplying together. Alright. Here is 4 equals to 4 times 3, 1 4 times 2 7 4 4 centimeters cubed out of 3 times 10. It is equals to, when you multiply here, what do you get? 2,000. 3,446,464 centimeters cubed out of that. Can it be divisible? Just divide this in the calculator. You'll get 114,000. 333. It's just 333, not 333 centimeters cubed. And they're saying correct the answer to 1 decimal place. So orange volume means in cubic centimeters as it is here. So another question is saying correct the answer to 1 decimal place. So it will be 114,800.
And use this.
1 cubic centimeter. So it will be 114,882.1 cubic centimeter.
Yeah, thank you very much, Precious, for being very, very good. Yeah, that you follow the lettering and you substitute accordingly, not so? Yeah, let us go to expanding brackets. Expanding brackets. Now, I think algebra is your beloved, not so?
Yes.
Expanding brackets. Then we shall also look at collecting some like what? Terms. Now, whenever you have a term, hope we see that.
Yes.
The term outside affects, it multiplies everything what? Inside. This would take us 2 times x, 2x plus 8. That flat?
Yes.
Negative 2 into y minus 3.
Negative 2y.
Negative 2y.
Plus 6.
Negative times a negative is positive. Not so?
Yes.
That's very good. This is your walkover, not so?
Yes.
Yeah, mixing this, then we solve equations. Simplify each. How did you, why are you managing them easily? Did you cover them well in primary?
Yes.
cover them well in primary. Now we are on like terms, not so? We are on like terms. To be like is to have the similar type of a letter, not so?
Yes.
Like X with X, then Y with. That means we collect 6X. Why not plus?
Because 12 is withholding that minus.
It comes with its sign.
Yes.
Then
Plus
4y plus,
6y.
then 6x minus 12.
Negative 6x.
That means you subtract number 6 minus 12. Then plus 4 plus 6.
10y.
10y. Let me add you more here. People are ready to handle, not so?
Yes.
Can we see somebody handling this in clear explanation? I hope this can be mine. Then we shall call in U3 to handle 3, not so? Yeah. We open up. U times U is 2. U times U will become
U squared.
Yes.
Plus U times 5
5U
minus U squared plus 3. No, minus 3.
negative times a positive 3U, not so?
Yes.
Then like a terms we have this, not so?
Yes.
That gives us 2U squared
Minus U squared
plus 5
minus
3U, giving us 2U minus U.
2.
We subtract the neighbors. What is this has a hidden one?
U squared.
2 minus 1, not so?
Yes.
When we maintain the letter, then subtract the numbers. This is 1U,
Yes.
which is U. You can say 1U or it is U. Then 5U minus that, we handle numbers. That is 2U, not so?
Yes.
This is now finally U squared plus, not so?
Yes.
Yeah. Somebody's head is working properly.
Yes.
I'll handle one more. Now there we're on this one. You are ready there? This one, how are we moving?
That 6W.
That will be
6W squared
then this
minus 9W minus
8,
8W
then negative plus
4W squared
4W squared.
6W squared plus 4W squared minus 9W minus 8W giving us 10W squared
10W squared.
minus 17
Negative 9 minus that is negative Because somebody would be wondering how you get, these are both negatives, these are 9 of them. Not so? Yes. You are now you're increasing more 80. Total they become 17. That means 17 W, not so?
Yes.
Okay. Guidance there. Then I'm calling in 3 people to handle for us this. Then we go and solve equations. This one you are guiding me. How can I collect?
3W
cubed
minus 6W cubed
6W cubed
plus 4W plus
6W. Here?
Negative 3W
W cubed
plus 10W.
Plus 10W. That's exactly.
Excuse me.
You are very much excused.
What if you have like W squared minus W squared? What answer do you get?
W squared minus W squared. What do you get? Because you are 2 minus 2. It's just now these are letters. Yeah, let me give you this, and we would like for people to come and simplify. I think we can have people to take over and simplify that. Hope I've quoted it right. Yeah, could we have somebody take over and simplify that? Then we shall have another student. Come and handle, simplify those. The first person. Simplify that.
The question is saying, work out A into brackets 2B plus C minus B into brackets 4A minus C. So 2 times 2B, which is equals to 2.
You have 2 minutes.
Okay, A times 2B equals to A 2B. A times positive C, which is plus AC, plus B times 4A, which is B 4A, then negative B times negative C, which is positive BC, so
That's where you end. Somebody wants help? Maybe to just say, when you are multiplying more than 2 letters, just arrange them alphabetically to AB, not so? A number comes first, not so?
Yes.
To AB, then A and C, AC, then here will be, what will be that? 4AB
Yes.
plus BC.
Yes.
Then these are like what? That is 2AB minus 4AB plus AC plus this 2 minus 4 negative, not so? But none of these are like, therefore you end what? Okay, you can take over this and we give you the last one. Take over that, you simplify. We give you the last one.
Plus 6 times 2, 12. Minus 6 times x, 6x. Equals to, carry the line count, 8x minus 6x minus 32 plus 4. 8x minus 6x is 2x minus 32 plus 12, 40.
That's very good, thank you. Let me have the yes correction. There is an error.
It's negative 20.
These are negatives being reduced by 12.
Yes.
Therefore, you get
Negative.
20.
Yes.
Okay, she added the mentally. Not so? Yeah. Now let us have somebody finally handle that. Then we go to solving.
Okay. Here we shall start by multiplying x times 4x, giving us 4x squared. Because x times x, that's x squared, plus x times y. Since you're multiplying 2 different letters, so you'll have to bring about the alphabetical order. X and y, which one comes first? So it will be x, y, plus y times 2x. It will still bring about this alphabetical order. So we shall have 2xy. A positive times a negative. It's a negative, so y times y squared. So we shall have, because these two are like terms and these ones are far different from each other, so we shall have 4x squared plus xy plus 2xy minus y squared. We are now collecting like terms. So it will give us 4x squared plus y plus 2y, giving us 3y. Now maybe active. 3y.
Now maybe active.
Minus y squared.
Yeah, thank you, Grace, for that correctness. Yeah. Okay, that's good. That's very, very good. Yeah, now let us turn to solving equations. Solving equation. I hope everything is okay. Are you okay? Precious, are you okay? Solving equations. Hope you are okay. Now, an equation is that algebraic expression that has equal signs. When we introduce equal signs, the expression is now being called what? An equation. That this is just called an algebraic expression. Algebraic expression. But when I introduce equal signs, it becomes an equation. Thank you. Thank you. Now, let us solve them here. Hope you are attentive. Solve each. Of course, you know them right from which level? From P what? From P2. From P2. We can start right away solving. Solve each for x. Me I want to sample like only 2. Then for we handle the rest. Now, here we have to first expand, not so? That gives us 2 times x, which is 2x minus 2 times 1, 2 equals 4. We collect like terms, or we take numbers on one side. Because this one is a negative, it must be added the other side. Therefore, you add it on both sides, and it dies naturally. 2x is equal to, you divide through by 2, not so? Here you receive 1, 6 out of 2, 3. That gives you 3. Yeah? I'm doing I'm still doing the first. Are we getting the next one? 3x plus 11. We move, not so? How do we handle that? Solution? 5x
minus 3.
When you cross equal signs, you change the sign.
Yes.
It's positive, it becomes negative 3x. Then this has to cross. It will become a positive. Therefore, you have 11 plus 3. That gives you 2x equal to 14. Out of 2, x equals 7. Now we go to number 2. I hope people want to help me here. Are you warming up? Are you warming up to assist me here?
Yes.
Okay, you can. I can receive the assistant. Is highly welcome.
Is it okay if I only work out x? The value of x?
It is okay when you work out both x and y.
Question 2 is saying the diagram below shows a rectangle. Work out the values of x and y.
Work out from there.
So, to find x, remember here, where x is, here there is x and here there is 24. This is the length and this is the length too. So we shall say length equals to length. So 3 into brackets x plus 3 centimeters equals to 24 centimeters. Remember, we have to only find x and there mustn't be any centimeters. So we shall divide both sides by 1 centimeter to get rid of these centimeters. So 3 into bracket x plus 3 equals to 24. So 3 times x, which is 3x, plus 3 times 3, which is 9, equals to 24. So 3x plus 9 minus 9 equals to 24 minus 9. Obviously, positive 9 and negative 9 is a 0. So 3x equals 15. So we shall make x the subject by dividing both sides by 3. Here is 5. So x equals to 5. But they have not only asked for x but also y. So we shall have to find y.
Okay, you want help on y? Fine, thank you. You have been very, very good. Will you have that space enough?
No.
Or we'll rub that? Okay. You are free.
Okay, fine, we shall work in the very simple way we worked it out. As she said, length is equal to length. So this is the width. So the widths are equal. So it will be width is equal to width. And then meaning 5y minus 4 centimeters is equal to 3y plus 8 centimeters. So it will give us, to eliminate the centimeters, since they're asking for only y, we shall divide both sides by centimeters. The centimeters and the centimeters will be cancelled, so we shall remain with 5y minus 4 is equal to 3y plus 8. And to remove brackets, you'll have to multiply nothing times this, so it will remain 5y minus 4 is equal to 3y plus 8. So we have to collect like terms. To bring this, because most times it is best if these unknowns are on the right. Like the letters are on the right, like y, x, all these letters have to be on the right. So we shall bring this 3y this side. So it will be 5y minus minus, since this is a positive, minus 3y minus 4 is equal to 3y plus 8. No, because we have subtracted 3y, so we have to subtract from both sides, so it will be 3y minus 3y plus 8. So here it will give us 2y minus 4, giving us 8. So we shall have to add 4 on both sides, since this 4 is a negative. So it will give us 2y minus 4 plus 4 equals to 8 plus 4. So 2y will give us 12. You divide 2 on both sides, giving us 6. So meaning y is 6.
Yeah, we thank you very, very much. Now, we thank you. We want to give you a word problem here. Are you ready? Kenneth thinks of a number. He multiplies it by 3, then he adds 8. He multiplies it by 3, then adds 8. The answer is 23. What is the number? The answer is 23. What is the number? I'm waiting for patience, not so? What is the number? How will she guide us? Okay, guide us from there. What should we do?
Let the number be.
Let the number. You don't want to say x because.
Why?
Okay, let the number be b. Then what do we do to the number?
So if he multiplies it by 3, so it has to be b times 3.
We have b times 3 plus 8.
Equal to 23.
The answer is 23.
So 3b plus 8 is equal to 23.
23.
Then 3b plus 8 minus 8 is equal to 23 minus 8.
Minus 8.
Yeah, 3b.
3b. 15.
3 out of 3.
B gives us
5.
5. Okay. Let me give you the other quite interesting one so that you can think well. Kate thinks of a number. Kate thinks of a number. She adds it to. She adds it to. And then multiplies the result by 3. And then multiplies the result by 3. Are you there? And then multiply the result by 3. The answer is the same as adding 5 to the number. The answer is the same as adding 5 to the number. then multiplying by 2. What number did Kate think of? And I think Tank is thinking of that number? Let number be what? M.
So it is M plus 2 times 3.
M plus
2 times 3.
times 3 where? Thinks of a number, not so?
Teacher.
Yes.
Adds 2.
Add 2.
Times 3. Yes, wait.
How will I multiply by 3?
So apply brackets.
I should apply brackets
Put the 3 out.
and put 3.
Meaning that's the result. Yes, because
This is,
after adding M plus 2,
then multiply by 3.
yes, multiply the result by 3. Then meaning that is also equal to
Equal to
5
5
plus the number that you have left, that is M,
plus M.
times 2.
Where?
Apply brackets.
Apply brackets times 2.
Then you solve so
Then I solve, solve.
you multiply around the outside with 3
3M plus 6.
equals to 10
10
plus 2.
plus 2M, not so?
Yes.
Now, why you like collecting in stages? Why not collect at once? 2 will come here, it will become negative, not so? Then 6 will move, become 2M, yeah? 6 will cross, becomes, this is 1M equal to, the same as M equal to 4.
Yes.
Therefore, Kate thinks of now. That is as far as equations. Now we are shifting to functions, the last sub topic. Functions. Yeah. Are you ready?
Yes.
Let me pick for you numbers here. Yeah. Functions. Now, let me to check what function would be. If we wrote y is equal to x plus 2, not so? This is an equation, not so? Yes. Now, x is being connected to y by this equation, not so? That means if I know the value of x, like if x was 4, you would be able to get y, not so? Now, a function is just a relationship between 2 or more variables. A relationship. Yeah. A relationship. Now, you need to listen and follow. Now, representation of Functions. Functions can be represented using what? An equation. An equation, this is called algebraic equation. For example, we said, what example did we say there? Y equal to x plus 2. Not so?
Yes.
Roman 2, we can represent it using a function machine. A function machine. How? For example, this same thing can be, you see the operation on here is plus 2. That you get y by adding 2 to what? To x. This one is x plus 2. Now, that each time I want y, I add 2 to, we show you x plus 2 gives us what? Now, this part of x is called the input. You feed in input, then this is called the function machine that does the work. Then you output from here. To output is to get the result. What could be the function machine for this? Or how would this be in terms of the function machine? This is A. If the function machine is this, how do we look at that? How would that equation be? How would the function be in terms of an equation? If this is a function machine? Yes, Grace?
I think it would
Y would be got by?
multiplying x times 2.
2 times x
Minus 1.
minus 1. That's exactly. Thank you. You are excused very much.
Does that mean that, okay, like, if we are finding for x, so I mean y, so meaning this y will have to be on the left side, not the right?
Yes. Because the input is on what? You feed in information into the machine, then you get the result. And it's just y is equal to, y is the answer you get. No, they will give you the type of function machine. We can give you even something of the sort. We say plus 3, then we give you a 2 here and ask you. We're going to do several examples. What is the output here? The output is 5. Just kind of, you just follow the arrow and follow the operations given. Yeah. Let me give you this. Now examples. Now we said it can be represented, there are 3 ways now as a mapping. First quote that as a mapping after this series of things. It can be an equation, function machine, or now a mapping, we shall see it in the example how it is written. How it is written. Now have this, copy and fill in. Copy and fill in the values in the table using the function machine. Copy and fill in the values in the table using the function machine. Copy and fill in the values in the table using the function machine. Using the function machine. Yeah. Now there you are. That copy and fill in, copy and fill in, and fill in. Are we right there? How shall we fill in that machine? X times 3 minus 2 gives y. Each student one answer here. What am I doing? Grace?
You shall have to substitute in for x, yeah?
Yes.
So it will be x times, 0 times
3.
Giving us 0 minus
2.
Negative 2 for 1.
Yeah, 0 times 3 is 0, minus 2. Also? Because the instruction is multiply by 3, then subtract 2. That means this gives us next,
multiply
1 times 3
minus 2, giving us 1.
Then 2 times 3
Giving us 6
minus 2,
giving us
4. Then here
3 times 3
that is
7.
7. Now I'll need guidance here. Write it as an equation.
X 3x
3x
minus 2 is
equal to y.
Shouldn't I write in the equation? I thought that maybe
You wanted it to be that side, eh? Or did it look very, very beautiful? Because math is the beauty. Did you know that? That math is beauty. It can't look beautiful and welcome. Now let us see as a mapping, how does it become? Now as a mapping, it's just we would have one scale having x values and another one what? Y. Then our x values are from 0 and so on. Because this scale ends on what? On 7. This one I can push mine 0, 1, 2, 3, not so? Yeah. Then here you can feed in from now the negative side, that is now negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6 and 7. I just draw lines that 0 gave us -2, not so? 1 gave us, yes, draw using straight lines. 2 gave us 4. 3 gave us 7. Yeah. Now we are trying to summarize. Alternatively, somebody can just use that this is x, this is, just feed in what you have here, then you're -2, 1, 4, and 0 went to this, this went to that. Yeah. Can use this scale, or I think I should pick a number from the new curriculum book here, and we ask one person to take us through, not so? Yeah, from the new curriculum. In case you had wanted, because sometimes you can have the value of y, but you do need it back x. If you have this answer here and you wanted to get x within a function machine, what would we do? In case you have this 4 and you wanted the 2, following this process, how do you get back the 2 to be x? In case you're using the machine without, of course the easiest way you would convert the machine into an equation, it would be directly solvable. But what if I wanted you to use the machine? You reverse the effect. When you subtracted, that means you just keep reversing the effects you add. Then if you multiplied, you divide. That means if you have 4, then you'd add it to give you 6, and divide now by, you just reverse. In fact, let me test you with 2 numbers and we close this. Okay, I think I should just have discussants taking on that, and we try to close. These are straight lines, class, not now fill in the table using the function machine. Fill in the table using the function machine. Let me quote that function machine, and I ask somebody to really think through that's x, that's divided by 2 plus 5 gives us y. Yeah. Then from your new curriculum work, I hope you visit your learners' books, not so? Do you or you do not? I'm trying to pick from the learner's book here. As somebody comes to discuss that, somebody discuss for us that, then we put the last number. Yes, Grace, you are very much willing. Yeah, you can. Discuss precisely or clearly and briefly.
Okay, according to the function machine, here we have divide by 2 and plus 5. And according to the table, x is given as 4 for this first column. So it will be, we shall substitute in, so it will be 4 divided by 2 plus 5 giving us y. So meaning y is equal to 4 divided by 2, 2 plus 5, so y is 7. So we shall also have, since this side we are given for y, so meaning y is equal to x divided by 2 plus 5. So for y it is given that it's 9. So it's 9 plus 5. So we shall subtract 5 on both sides because 5 is a positive. So it will be 9 minus 5. So it will be x out of 2 plus 5 minus 5, giving us 4 is equal to x out of 2. So here we shall get, what's the LCM of 1 and 2? That's 2. We multiply both sides by 2 times 2. So 4 times 2 we get 8, giving us 2x, giving us x. So meaning x is equal to 8. And let us first try to substitute because I'm also not sure. So it will be 8 divided by 2 plus 5 giving us 9. Let us try. By 2 this is 1, by 2 this is 4, 4 plus 5, that's 9. So I think it's correct. So we got to find for y. So it will be y is equal to x, that is 10 divided by 2 plus 5. So this can give us 5. So y is equal to 5 plus 5 giving us 10. what? Because here it's x, which is 10, divided by 2, 5, plus 5, getting 10. So y is 10. And then finding for x, it will be x out of 2 plus 5 is equal to y, 15, which is 15. So meaning x out of 2 plus 5 minus 5 is equal to 15 minus 5. So x out of 2 is equal to 10. Make this one a fraction, multiply both sides by 2, since the LCM of 2 and 1 is 2. So you will get 2x, no? X, sorry. This will be x is equal to 20. So here the x is 20.
Thank you. Though you didn't want shorter roots, not so?
Yeah.
Okay, thank you very, very much. I think she found those. Those are the values she found. I just wanted to add a little that in 7. Now, if you wanted this, x, that is 4 divided 2, mentally not so. 4 divided 2 is 4 divided by 2 is 2 plus 5, 7. If you wanted the 8, you reverse the order. This is y, you start from this way. When there is plus, you subtract 9 minus 5 times 2, 8. Yeah, you just reverse. Thank you very, very much. Grace, answer this and we can close which value.
But then, teacher, what if you get bigger numbers?
Like?
Now, maybe you get, if possible, you get that. Can you use that? Can you represent the function using a map? Using this number?
No, that means you'd opt for this representation. Can somebody help us with what comes out of that machine? Yes, and that will shall close our session. Yes.
7 minus 3, the answer will be 4.
That's how it will be 4. That means the machine produces out a 4.
But teacher, there is something I don't understand about the machine.
There is something that you don't understand about the machine of mine. Yes.
Okay. Is it just like mentally, or it is also physically, like it can, I don't know how to...
Yes, these are actual machines. You can use them to play games. Okay. And I think those people who bet, they have some rotary machines for betting. Where they put coins, and the coins they multiply for them money if you gamble well. They are actually used. Now we have ended, and I'm giving you activity of integration. Now it says that let me give you the activity of integration. I think I'll give that activity in the next discussion, but then visit the learner's book for the new curriculum and do more and more numbers. There are some books for secondary for the old curriculum that can have many of this work. Yeah, that means we meet from there. Students, thank you for being a very good class.